In recent years, the landscape of infrastructure maintenance has been undergoing a significant transformation. Imagine a world where drones soar through the skies, inspecting vast expanse of power distribution networks with unmatched speed and precision. That's the reality we're venturing into today. UAV technology has entered the forefront because of its unparalleled ability to cover extensive distances, especially in terrains that are often inaccessible. This is not mere science fiction. It is happening now, demonstrating transformative potential. At the core of this thrilling advancement in UAV technology is a powerful innovation known as the MARL-SOM-GNNs network model. This pioneering model integrates three key technological pillars: multi-agent reinforcement learning, self-organizing maps, and graph neural networks. Each of these components serves a distinct purpose that collectively enhances the UAV's capability to conduct inspections. Multi-agent reinforcement learning enables our drones to make dynamic decisions in real time, improving how they work together in coordinated efforts. Imagine a team of drones learning from their environment and from each other. That's the essence of MARL. Now, let's talk about self-organizing maps, often referred to as SOM. You might wonder how something as abstract as a map could aid in UAV inspections. The brilliance of SOM lies in its ability to neatly organize and visualize complex, high-dimensional data collected during inspections. By clustering significant data points, drones can swiftly identify and prioritize areas of interest. This capability is pivotal when dealing with the massive amounts of data generated in real time during UAV operations, allowing inspections to be both efficient and focused. Then we have graph neural networks, or GNNs, which may sound a bit technical, but hear me out. GNNs empower our UAVs to understand and navigate the intricate relationships present in power distribution networks. This means knowing where each power pole is, which transformers are nearby, and even predicting potential risks. The insights drawn from GNNs are critical for effective route planning and comprehensive inspections. As drones operate, they use GNNs to navigate the most efficient paths through these networks, ensuring that nothing vital is overlooked. However, as tantalizing as these advancements are, they do not come without challenges. Even with such cutting-edge technology, researchers face hurdles like coordinating multiple drones efficiently and processing the vast array of data they collect. One of the pressing issues is ensuring that these drones can adapt to dynamic environmental conditions like sudden weather changes or unexpected obstacles. Despite these obstacles, the integration of intelligent algorithms into UAV operations promises to create a more resilient and efficient infrastructure management system. The experimental results for the MARL-SOM-GNNs model are nothing short of impressive. In testing, this new model has shown remarkable improvements in inspection accuracy, achieving a staggering 93.39% accuracy on the GRSS dataset and an incredible 96.21% on the ISPRS dataset. These numbers signify a leap towards practical implementation, proving that equipped with intelligent algorithms, UAVs can inspect critical infrastructure with higher precision than ever before. Imagine a world where maintenance is preemptively handled based on predictive data. This is the goal we're striving for. Looking toward the future, the prospects seem bright for this technology. As we continue to refine and optimize the MARL-SOM-GNNs model, the applications extend beyond just power distribution networks. Industries can leverage these intelligent UAVs for a variety of inspection tasks, from surveying utility infrastructure to monitoring agricultural lands. The key takeaway is that intelligent algorithms like the ones we've discussed today are paving the way for smarter infrastructure management, leading to safer and more efficient systems. It's exciting to think about how we can harness this potential for better public service and resource sustainability. In conclusion, this video offers a snapshot of a remarkable intersection between technology and infrastructure management. The MARL-SOM-GNNs network model is not just an academic effort, but a stepping stone towards real-world applicability. It demonstrates how we can enhance the capabilities of UAVs through intelligent algorithms, ultimately revolutionizing how we approach the maintenance and inspection of critical infrastructure. Thank you for joining us today at All About AI Tech. We hope this exploration of intelligent, self-organizing algorithms has inspired you as much as it has excited us. Stay tuned for more insightful discussions about the transformative power of AI in our world.